Thiago Passos here at NDC Sydney. Today I'll be doing an Ask Me Anything interview with former astrophysicist James Lewis. These days, James works as a developer and coach at ThoughtWorks, introducing evolutionary architecture practices and agile software development techniques to various blue-chip companies. Thanks for joining us today, James.
Thank you very much for having me here in rainy Sydney.
Yeah. I hope you're enjoying NDC.
Very much so, yeah.
Your talk yesterday was pretty amazing. It was the last talk of the day, and for me especially was a very relaxing talk and very entertaining with a lot of history. Do you want to talk about more about the evolutionary architecture that you covered in the talk?
Yeah, I can talk a bit about that. I mean, I think I explained yesterday that I'm a firm believer in telling stories as a way of communicating our ideas to the wider industry. The talk yesterday was really, it was the story of building a replacement science publishing platform in a greenfield program of work to replace a sort of 15-year-old C++ service-oriented architecture, which was earning a tremendous amount of money every year. So it was about the sort of decisions we were making as we were going. So how could we explore what the correct decisions or better decisions might be as we sort of designed and built this software in parallel. I mean, ThoughtWorks, for a long time we've been known as an agile development shop. So practicing XP and then maybe a bunch of the sort of Scrum practices on top. So if you're in that sort of position, you tend to think about building software in a slightly different way. Tend to focus a little less on upfront design, which means you need other techniques to come to make design decisions, if you like. So the talk was about that, how we experimented with various different options, how we placed lots of small bets. I think that was the idea I was sort of trying to communicate, rather than do all this thinking up front and then bet the house on bet everything on red or whatever.
So the other question I have is about microservices. So microservices has been a buzzword for a long time now, and you were one of the first that talked about microservices. Nowadays, do you think microservices is like the silver bullet, or do you still go to a monolith application if you had the option to choose?
Sure, I mean, that's a really good question, and I've got a simple one-word answer to the silver bullet part of it, which is no. There are no silver bullets, definitely. I mean, microservices for me, it was an interesting journey that I think took the industry to this place, and I'm under no illusions that others weren't working in this space as well. At Netflix, Adrian Cockcroft was he was building or helping their teams build something called a fine-grained service-oriented architecture. That's what he was referring to. A couple of years before, or just before Martin and I published our paper, Fred George was also using the word microservices to describe a very particular style of sort of almost functional sort of architectural style. So this is where you have a small process that accepts an input, maybe a message, does some stuff and produces an output message of kind of functional style. So, I mean, my journey with this, I guess, I've been very, very lucky, incredibly lucky over the course of my career, especially at ThoughtWorks, but also with people I worked with previously, to work with some amazing people. Microservices is very much one of these things that's a shoulders of giants thing, right? So, I talked early about the Unix principles. A lot of the ideas in microservices are not new. They go back 40 plus years to the pioneers of Unix. The Art of Unix is an amazing book, and it sets out these principles. And and you can see the reflection of that actually in what we talk about with microservices. So things like the smart endpoints and dumb pipes. That's very much taken from the Unix philosophy. So where it came from, I guess, was for me was being a part of an amazing group at something called the Software Architecture Workshop, which happens once a year, which I'm a part of. And there's a real cross-disciplinary group, if you like, cross-disciplinary in the sense of the IT industry. So there's people from the sort of domain-driven design community, from the RESTful community, lots of really smart people. And there was one year where we all sort of started, we were all talking about similar things, and it was about this thing we've got is unmaintainable, or it's really hard to add new features to our product. How do we take our product and split it up? And it was sort of a revelation, I think, for the group at the end of that 3 days that we were there, that maybe we were solving the wrong problem, trying to maintain these old big things, and maybe we should solve a different problem, which is build things that are smaller, so break things up. And again, we've long, as an industry, sort of recommended not building in horizontal layers, and building these vertical slices based around business functionality, and that sort of ended up in the sort of microservices article as the building based on business capabilities and things. So, but a lot of these things aren't particularly weren't particularly new or revelatory. I think it was a bit like extreme programming, actually. A lot of the practices were in place, but I think the genius was to put them all together and turn it all up to 11, And I think that's maybe the microservice thing has caught on because it is just doing a bunch of good stuff, but doing it all the time,
So one of the things that you talked yesterday that I found quite entertaining was the story about taking the man to the moon. And the whole process and how that fits into software development and the agile way of architecting the software and stuff like that. Can you tell us a bit more about this story? Because I'd love to hear that again. In a succinct way.
Because we could be here for the rest of the day, actually, if we talked about it too long. Yeah, absolutely. I mean, so I should full credit to an amazing guy called Russ Olsen, who he works for Cognitech now. He's written lots of books. He's written quite a few about Clojure recently. I first saw him do a talk keynote called To the Moon at QCon in London a couple of years ago. It's the most extraordinary journey talk he did. It was the story of him as an 8-year-old watching Neil Armstrong become the first person to walk on the moon. It's so amazing. In fact, I've never seen an audience where there were people, there were developers in the room with tears running down their face. It was a really moving experience. And so that inspired me to do a bit more research. I'm not quite that. I wasn't there in person at the time, right? And actually, what you sort of see when you look at the Apollo program is how it's kind of they didn't run it in the way that, as a non-layman or someone who's not a rocket scientist might think. I posed a question yesterday: what does the Gantt chart for the Apollo moon landing look like? And I sort of had this linear Gantt chart of design the thing, build the thing, launch the thing. A very
waterfall.
Yeah, a waterfall approach to going to the moon. And after doing research, it became clear that that's obviously not what.
That wouldn't be the case. Yeah.
You can't do that. I mean, for the simple reason that you can't risk killing people. Space is a very hard environment, and at the time we didn't even know if we could hit the moon with a rocket. Never mind get people there and back. So this idea of that they used the scientific method. Really, they ran a series of parallel experiments in as low a risk a way as they possibly could. So humans were close to Earth still for the Gemini program. For Ranger, they were just firing rockets at the moon to try and hit it. It's a really interesting. I think it's really interesting from the agile perspective, because I mean over the years the way I've come to see agile. I think Randy Shoup said this on Twitter recently, that agile is basically 3 things, right? It's small batches, working in small batch sizes, it's fast feedback, and it's engineering discipline. And if you've got those 3 things and you can continually learn, that's really what agile is. And I think you can look at the Apollo program, and that's essentially what they were trying to do. They broke the problem up into smaller parts. They tried to get as fast feedback as possible by running lots of parallel experiments. And it's NASA, so engineering discipline is a thing, right? Yeah. So, yeah, and so I think looking at that, taking lessons from these sort of great human endeavors, actually, and looking at how we solve problems in extremis. I think there's a lot we can learn from that. So
it's all about the observe, run, and improve, isn't it?
Yeah. I mean, well, I think I used a loop yesterday to talk about running experiments based on Richard Feynman's description of the scientific method, which he says, I can't remember exactly, but to paraphrase, and I really like this idea that the great Richard Feynman should say, first of all, when we're running an experiment, first of all, we make a guess. You know, there's this great series of lectures on the character of physical law, I think it's called, which you can watch online. Stanford hosts them, and you can see him describing this. And as he says, first of all, we make a guess. The entire lecture theatre starts sniggering. You know, this is, what do you mean we make a guess? That's ridiculous.
That's how everything starts.
Yeah, first of all, we make a guess about how to improve things, or what a new law might look like, and then we compute the implications of that guess. We compare the implications to nature by running experiments potentially, or these days we do a lot of modeling and simulation, and then we form a conclusion based on whether our guess agrees with experiment. And he says that, if it doesn't agree with experiment, then it's wrong. So my observations yesterday were, how can we use this approach, this very closed loop, to make difficult decisions, or to change things that are hard normally to change. Software architecture.
Yeah, and that's pretty much how you do with software development as well, and how you choose the architecture. And architecture is something very, very hard to change, and to come back and make this change later on, it's going to be very hard. With all these years that you had behind you, what was the hardest decision that you had to make to go back in time, a decision that you made? And what was the most expensive one that you encountered?
My brain is saying, yes, I've got a really good example, but the other side of my brain is going, I'm not sure if you should talk about expensive things as a consultant.
No, not money-wise, but time-wise, because sometimes you make a decision and you think, all right, so I'm going to do Spike, and I'm going to go for a week, and then you can go back a week. But sometimes you just halfway in the project, and you have to change something that you started in the beginning, which is very hard. Sure. So how did you handle that?
So I'll make the same joke I made yesterday, so apologies if you heard this before. But the structure of the talk, if you like, the conceit I used yesterday was that of a choose your own adventure novel, right? So this is one of these things where you go on a quest, you make decisions as you go. And I made the joke that choose your own adventure was a gateway drug for Dungeons and Dragons for a lot of people, including me. And someone else, Mike Nygaard, the author of Release It, when he saw me do this talk, he sort of made the observation that we used to keep our fingers in the book, right? So we could go back in time by just, oh, I've died, okay, well, I'll flip back and I'm fine. And he made the observation that that's the gateway drug for version control. I really like that observation. It's like, it's Mike Nygaard, so it's like, oh yeah, okay, thanks Mike. I should have realized that already. That should have dropped. And I think probably the most difficult thing I've said, well, not difficult, but probably the biggest thing that I've had to sort of go back in time was a complete change of programming language about 3 months into a project. Oh, wow. So the scenario was, we started off for a number of reasons in writing code in Scala, and sometime in, we all as a group decided that we would be better off in Java for various reasons, which I won't go into because dull. And so I mean that's a big choice, right? That's a big thing. But I made the observation yesterday that a programming language is hard to change if you've got a big monolithic thing. This is one of the first, I guess, real distributed, some microservice style projects I worked on, and we'd broken things up into pretty small bits. So actually, the rewrite, and again, it's Scala to Java, so we just added some semicolons more or less, right? But the rewrite took place over the course of about 2 weeks, and we could attack each individual piece independently, and actually continuously deploy those as well. So once one individual microservice was rewritten,
you can deploy and
then you can deploy, and the overall behavior of the system is still the same. And after about 2 weeks, we'd migrated the whole thing. So I mean, that's not ideal, and that's not exactly just going back in version control. But I think it does illustrate the point that things are becoming easier to change. Things like programming language. I remember, I don't know if you've come across a guy called Chad Fowler. He's very well known in the Ruby community, and he was CTO at a company called Wunderlist, which has been acquired by Microsoft. And Chad had a rule at Monolith, which was you could write your services in any language you chose, but there was a couple of constraints, right? So guardrails around this. The two I can remember, there were probably more, is that you must be able to print the code out and show it to someone who can't normally read or write that language, and it must be readable to them, right? So things, Haskell, you can write something in Haskell, but if you print out the source code, and I don't know Haskell, I should be able to read it, right? And that was one. There was another one which was, what was the other one? It was, I think it's like you had to be able to rewrite something in a day. So, really small things that were really readable, and those were the constraints you put around it. And if you've got those kind of things, these kind of modular architectures, they do make formally difficult things like programming language much easier to address. I mean, with a monolith, you've got a million lines of code in running in one process.
That's hard to make changes like
that's gonna take some doing.
You also talk a lot about cloud native and infrastructure as a code. Can you elaborate that a little bit more, and where you use it, and is that part of your day job?
Yeah, good question. I mean, again, very lucky I work for an organization like ThoughtWorks, who, we're not completely at the bleeding edge. We don't, generally as a consultancy, we're working with organizations to try and move them towards the bleeding edge, if you like. Although we do work with the big tech giants as well. And I think, as an organization, we sort of very early on understood the importance of the cloud, of going to the cloud, and some of the different decisions you can make if you are on the cloud. I guess an example, I can't remember exactly what number, but I was, and this is back in 2011, I think, I was something less than 10 of the first Amazon Web Service trainers in the world, because we had a thing with Amazon at the time. So very early on we were using Amazon Web Services and deploying code into production. Similarly with infrastructure as code, I think back in the UK we had our own clean room implementation of something that was pretty much Ansible, again back in 2011. So having adopted this pretty early and have been using it ever since, I'd probably say that 95% of our projects in the UK, I can't speak for the rest of the world, have some, or are using the cloud and are using infrastructure as code. But I think it's interesting what happens when you sort of innovate on top of that. You get interesting things start happening when you plug different things together. And an example is something that appeared in our tech radar, which is this idea of pipelines for infrastructure as code. So much like with feature code, we make a change, push it to version control, and we have a build pipeline that progressively tests whether that code should be released into production. The idea that we could do that with infrastructure code as well.
So you can bring the whole environment and do an integration test with like a environment.
Yeah, for example, that's a good example. Or if it's a small change, we want to change the instance size, say, of this set of services. That's pushed through a build pipeline rather than it. Well, the old days it would be either phoning someone up, right, and saying, "Can I have a bigger box?"
Talking to the IT guy.
Yeah. Kate in ops, and or it would be SSH, well, not SSHing, but logging into your Amazon console, starting a new one and killing the old one. Actually, the ability to treat that sort of code the same as we do any other sort of code, I think that's really powerful. And it enables us to do interesting things, I think, like this roll back and roll forward. And,
so when we talk about cloud native, a lot of people think about cloud native as being a cloud agnostic. So you can go to any cloud provider, like Azure or AWS or Google Cloud Services. Did you find in any of the projects you worked on that the client wanted to move from Azure to Amazon or the other way around, or what challenge you have?
Yeah, no, that's a really good question. Thank you. I'm maybe going to be slightly controversial here because I mean, there are sometimes good reasons to want to run across many different providers. But I think a lot of this is FUD as well. So, I remember back in the day, where everyone was really excited about JDBC drivers in Java, right? Because, hey, we could swap Oracle for SQL Server, and you know, no one ever swapped Oracle for SQL Server. It wasn't a thing, right? I mean,
it doesn't happen often.
No. I mean, not least because you've got a 10-year contract with someone, and the licenses are written, you know, are capitalized, and you've got to wait 10 years before you can do it. And I think probably that's similar now. What I do think is interesting, and we had this on our tech radar as well, is the concept of polycloud. Which is subtly different. So this is the idea that we should be able to take advantage of the good stuff each platform provides. So not be forced into one ecosystem and say, if we're using compute from Amazon, we'll also use their data tools, or we'll also use their machine learning tools. But we could say, we'll use compute from Amazon, but we're going to use TensorFlow to solve problems that are TensorFlow shaped. So that I think is an interesting idea, that we can actually pick and choose the different cloud, the different offerings that the different cloud providers.
To pick the best of each
To pick
provider.
the best, exactly. So the right tool for the job, and this is, you know, again, it's an extension, if you like, of.
Does that make
the
harder to
microservice thinking.
maintain as well, or not really?
Well, only in the same way. Well, actually, back it up a bit. I mean, it makes it harder from a contractual point of view if you're a giant organization, right? Because suddenly you're managing enterprise contracts across multiple providers. But, you know, I'm not so sure if it makes things hard to maintain. And anyway, I think these days we should be throwing away and rewriting and not maintaining.
Yeah, that's true. So with all the projects that you worked on, what was the most exciting one that you worked?
Good question as well. And there's, the reason I'm sort of pondering this is because it depends upon which axis of interesting, right? So I worked for a really fun organization called Compare the Market. I think they're in Australia. So they're the Meerkat insurance aggregators. And that was really interesting because it was a move away from a monolith towards individual product lines of business, composed of microservices, with teams formed around those things, and it really demonstrated to me the benefits you get from the inverse Conway maneuver, if you've come across this. So taking advantage of Conway's law rather than fighting against it. So that was really fun, mainly because there were great people there, but also people were willing to try new things. They had really courageous leadership. And over a period of time, we successfully managed to migrate a number of product lines away. So that was really fun. The technology wasn't particularly exciting. It was C#, and we were using CQRS. Thanks, Greg, wherever the cameras are. But it was a pretty vanilla technology stack. But I think it was when I really saw what could happen when you did give people the space and the trust and the autonomy and the purpose, to achieve an outcome, and they had enough of that space to get stuff done on their own. So that was really fun. I've also done a bunch of other more interesting technical stuff over the years, but from a technology perspective. But that probably was my most fun.
Cool. And what are you gonna do next? Like, what's your plan for? I don't know, for any exciting talks you're planning, or any exciting projects you're gonna work on in the future that you're looking forward to? Or, I don't know, anything exciting that you're gonna do?
Yeah. So shout out to a couple of books first. So Sam Newman's Building Microservices book, which is really good, and I'd recommend
the second one?
Well, the second edition is on its way, I think, if it's not out already. It's really, really good, and actually it's the reason I never wrote one, because it's kind of, as Martin Fowler kind of said, well, it's annoyingly good, this book. I think we should, there's no need to write one.
Right.
Yeah, originally Sam and I developed the microservices workshops together back in 2013, I think it was. Not a microservices book, I think, is the sort of next thing was maybe a travel log, stuff. The great thing about ThoughtWorks, or any consultancy, as I'm sure you know, is you get to work on lots of different things, right?
Yeah,
solve lots of different problems.
That's the nice thing about working for a consultancy.
There's this whole I can't remember the exact phrase, but you know, you can have 10 years of experience where every year is different, or you can have 10 years of doing the same year over and over again, and that's not the same.
Don't learn at
right?
all. Yeah,
and that's not a problem when you're working as a consultant. So you know, taking maybe a whole bunch of experiences and slamming them together in some form of travelogue would be fun. And then Gregor Hooper, he published 37 Things One Architect Knows.
All right.
Maybe it was last year. He's a good friend of mine, Gregor. So that kind of put the kibosh on that one as well. Right? I seem to be just a little bit too late when it comes to writing.
And what are the 37 things that an architect needs to know that you think?
Well, that's a
most
secret.
Important?
You have to read the book. Yeah.
What's the top 5 that you
I
think?
can't remember, to be honest. It was a while ago where I read it. I really like his ideas. Are actually, I mean, Gregor's a real deep thinker. He's at Google office of the CTO these days, and he's a real deep thinker about stuff. So it's always worth reading whatever he talks about. He's got this really nice shortcut to identify what sort of organisation you're working in, and whether they're focused on cost cutting or whether they're focused on innovation and things. And his observation is, to first approximation, if you look at who the CIO reports to, that'll tell you what's important in the organisation, which is an interesting idea, right? So if the CIO reports to the chief financial officer, you're probably looking at an organisation focused on cutting costs. And probably the strategy.
That's a great point.
Yeah, and probably the strategy that they're going to be looking to follow is to outsource, right? Whereas if you're looking at an organisation where the CIO is on the board, as a full member of the board, you're probably in a much more innovative organisation, and you're probably looking to take advantage of agility or economies of flow rather than.
That's a great way of looking.
Isn't it? Yeah. I mean, this is Gregor. He's awesome. Yeah.
Okay, so I'm gonna wrap up. Thank you, James, for coming. That's Thiago Passos for SSW TV.